Hello students, welcome back. This is a continuation from the previous video, but as you can see, I changed the notebook structure a little bit. It is turning out that it was apparent that section 1 was getting too long, so it used to be called Riemann sum and Riemann integral, but I divided the Riemann sum part and Riemann integral part, and then I'm naming it sections 1 and 2 now. So in section 1, we went through Riemann sums. And then in section 2, we defined Riemann integral. And then we went through one example problem. Now let's recap what we did for this exercise problem. The easier answer was this. 1 over n becomes dx, k over n becomes x, and the rest becomes integral from 0 to 1. How? Well, there you go. I can move this 1 over n to the right-hand side here, just a multiplication, and then more importantly, this n going to infinity, rewrite it as 1 over n going down to 0. That's the equivalent, isn't it? So here, n going to infinity, here 1 over n going to 0. Now that's going to 0, and then compare that with the definition of the Riemann integral here. Delta x is going down to 0, and then this one here, I'd like to have a little bit different version here. Okay, and then we are dealing with continuous functions, so yi stars can be rewritten as f of xi star. Okay, so all right. Compare, and then this one we got is 1 over n. And then that's going to become dx, because that's the infinitesimal version of difference of x coordinate. Now, how about the summation part? Summation part, let's see. No, let's work on summation part a little bit later. And this part is the function part, f of xk star part. And that's got to be this one. And then in the end, we get the integral 0 to 1 f of x dx. Okay, 1 over n becoming delta x, and then becoming dx. That was easier to understand. Oh, delta x. That's easiest to understand, the red part. Now the blue part is the hardest. How do you get f of x accordingly? Now the green part here, that's medium. I can understand it like this. k is going from 1 through n, so 1 over n, 1 over 2, 2 over n, 3 over n, and so on, right? And then eventually I get n over n. And n over n is 1, and 1 over n is, well, not equal maybe, but approximately equal to 0, and upon taking the limit, it is 0. So this thing is starting from 0 to 1, and all this thing is Riemann sum, so that's why we are getting integral from 0 to 1. Now, the hardest part. What is f of x? So we did this part. The hardest part is this one. It turns out you can change k over n to x. So k over n is x. So this whole thing will turn out to be sine of pi. No, sine of, yeah, like this. Okay, all right. And then here, sine of pi x. Okay, good. Calculating this integral is an easy thing to do. Just use the fundamental theorem of calculus to do your computation. No problem there. The hard part is getting here. Look at the scheme. 1 over n is dx, k over n is x, and the rest is integral from 0 to 1. Limit n goes to infinity, that's always, and summation k going through 1 through n is integral from 0 to 1. Now, how do I understand this? Well, I told you it's the hardest part. Comes from this kind of picture. Turns out it's a right-hand side approximation of the Riemann sum. Right-hand side endpoint of this degenerate rectangle, which has height 0. Right-hand side endpoint, right-hand side endpoint, right-hand side endpoint, those are xk. Left-hand side endpoint is xk minus 1. That's not what you're looking at. You have xk. You see? K pi, not k minus 1 pi. So this should be xk going from 0 to 1, so x times pi. So k over n is x. So we end up with this scheme. So if you follow this scheme and put it in, you can re-express this into the definite integral, and then you can calculate it. So if you see everything from this comparison, the definition of the Riemann integral and this, that'll be great. But for the majority of the student, it's going to be very, very, very hard thing to do. So let's do it this way. Oops. So let's just move 1 over n here. All right. This is integral, right? So that's going to be the integral. Oh, wrong place. That's going to be the integral, 0 to 1. And this is dx. And then that is going to be my f of x, where k over n is x, so pi will stay as before. There you go. Make sense? If I create another problem like this, can you do it? For example, now instead of sine, let's change this into something different. Okay, can you do it? So 1 of n is dx, and then k of n is x. So this whole thing becomes integral from 0 to 1. And then this whole thing is 1 minus x squared. Do you see it? And calculating this integral using the fundamental theorem of calculus is going to be an easy deal for you. Okay, how about this? Looks a bit challenging, right? Instead of 1 over n, we don't have 1 over n. But no, you can change it like this. And this is dx now, and all these are function. So we have integral 0 to 1 dx. You see, this red is my dx. And then this green is my integral. And then here I have x square root of 1 plus x squared. Which I'm highlighting in blue. K of n is x. And can you do this integral? Well, that's a bit more challenging. You'll have to use integration by substitution, but you can do it. So that scheme works almost all the time. Please remember this. But there are cases that it doesn't work. And this is one of those rare cases, and that's because of this too. So how do you make it work is a question, the final question I leave to you. In this case, this is not gonna be just simple integral 0 to 1 this is not going to be equal. Now, this will be perfect. This is right. The same scheme applies, you see. The scheme here. 1 of n is dx, k of n is x, and that limit summation case going from 1 through n, that's integral from 0 to 1. So everything is okay. That is having okay. This is equal. But no, not this time. This is now 2n. So I have to make appropriate change here. How do I do that? That's my final question. Think about that. In the end, you're going to get 2. Why? Think about that. The answer is hidden here. If this is, say, 5n, this is going from 0 to 5. Think about why. Alright, that'll complete section 2. Previously, section 1, where I had Riemann sum and Riemann integral together, but I now separated. We're going to talk about section 3 in a separate video.